Hello, ladies and gentlemen. This is Mr. Huff, and I would like to go through a lab we did in class that you weren't here for, but I want you to benefit from the experience nonetheless. All right, so let's take a look at this. These are two kinds of fiberglass, and we have on the top we have bidirectional fiberglass. That means it's woven together like fabric. We have strands that run the length and the width. The other type of fiberglass that we have is called unidirectional, and in this case, the fibers only run from one end to the other. There are a few that kind of straggle around in here, but most of the fibers run the length, but none run the width. This is called unidirectional. This is called bidirectional. This is West System epoxy resin. It's an odorless resin, and this is what we used to bind the fiberglass together and apply it to some foam pieces. So you can see some samples here. This is the testing device. I'll talk more about that in just a moment. But these are some of the samples here. We had 1 inch thick by 2 inch thick foam. We had 2 inch by 2 inch thick foam. And we had another piece of 2 inch by 2 inch thick foam. We had pink foam. This is closed cell foam. And then we have this foam here. This is more like what you would see in a cooler that you buy from 7-Eleven, those little foam coolers like that. So you can see that we've got some, let's go to a better picture here. You can see that we've got, see, the fiberglass on the top and on the bottom. So this one didn't have any fiberglass. This one has fiberglass on the top and the bottom. So does this one, and this one is just foam by itself. You can see the indent here. This is from testing where we have permanent deformation because of the force we applied. Here are some more samples. So these have yet to be tested, where we have 1 inch thick by 2 inch wide with unidirectional fiberglass on top of this one. Notice that it's see-through when you have the epoxy on it. Okay. Then we have these pieces of foam. We have a couple of test pieces here that are just fiberglass, and you can see that we had multiple samples to test. This is the testing jig we used. This is the vernier structure measurement tester. And what you do is you put your sample up here, and then you put this piece on it, and then you spin this wheel at the bottom. It applies a force pulling down, and it measures how far down it's moved and how much force is being applied. Okay, and so here you can see the sample. Right now, these are set really close together. This is about 4 centimeters apart. For most of the testing, for testing these larger pieces, these were set 20 centimeters apart. But the data for that is all recorded for you already. This is a screenshot of Logger Pro. This is what the data is going to look like for you to analyze. You can see you have a data set here. So we have the time, the force applied, and the displacement in inches. The force is in pounds. It produces two graphs. We have the force graph on the top and the displacement graph on the bottom. What you want to look for on the displacement is this uniform increase. So the person spinning the wheel is going the same speed, and then right here you can see that we stopped, and it was interesting that when you would stop applying a force, that the force applied would kind of drift lower and lower. Okay, so let's talk about the data you're going to get from these curves. One of the things you can do is, I have another video for this, but you can select a region and it will highlight some of the numbers over here to show what you have selected. All right, this is a curve. We need 3 points of data. I'm not going to get fancy and have you do linear regression and all that, but what we want to focus on are 2 kinds of information. One is for the modulus of elasticity. We need to know the force and the displacement. I want you to notice this zone right here. When we first start applying force, this is a fairly linear trend. Okay, so this is the one we're interested in. What you can do on your analysis, you can zoom in on that and choose something that looks pretty close to the middle. Because of the way the equation for modulus of elasticity works, because this is linear, you can pick any point on this line and get a accurate modulus of elasticity. So you need to select a region here and pick a point, or you could do multiple and do some averages if you want, if you're feeling saucy. But really you just need, for the purposes of this lab, like grab a point in here that looks like it's about along that line that would cut through this, and you can get the force and the displacement for a point in here. This is going to be used for the modulus of elasticity. The other thing we need to find is the ultimate force. So you will choose a zone by selecting it up here that has the highest points in it, and then click on the statistics button right here. This is the stats button, the 1/2. You're going to click the statistics button and find the maximum force applied, and we're going to call that the ultimate yield strength. All right. So things I want to point out in this elastic zone: if you release the force, the sample will return to its original shape with no damage. Once it starts to flatten out, you have permanent damage occurring, and the part is no longer viable. It's not good. So if you had an aircraft and this was stress on a wing, if it lived in this zone, it would be just fine. But if you ever overstressed it to this point, you would need to replace the wing or the structures that were damaged. All right. When we get into analysis, you're going to look in a folder and you'll see these 3 items. We have a sample map and then 2 folders, one for a program called Graphic Analysis and another one for the program Logger Pro. If you're using the student computers, you have access to Logger Pro. If you don't have access to the student computers, you need to search for Veneer Graphical Analysis, and you can get the application for free and download it and put it on your own personal computer, and it will do exactly the same thing. I have supporting videos for both of these, so let me know if you have any questions there. All right, when you look at the data table, you'll see the ID of the sample. We've used letters, and I have a file name here that it corresponds to, but basically we have different kinds of foam. We have no foam at all, 0. We have 1-inch thick foam, and we have 2-inch thick foam. All of these samples are about 2 inches wide. As far as color, we have 4 kinds of things going on. We have nothing, we have white foam, and we have pink foam, and we also have one sample in here labeled tape, and I don't see it. Oh, there it is. No, it's pink foam, and we have tape on it. So we have one sample that is kind of strange. Then right here, we have the type of fiberglass, either bidirectional or unidirectional. We also have one with just packing tape on it, and then we have some pieces. If it says none, there's no support structure whatsoever. So these are just pink foam, white foam, and pink foam. Okay. These are the base and height and length measurements you need for calculating the moment of inertia, and then moment of inertia and length will be used to calculate the modulus of elasticity. All right, so when you look at the file names, these are the files for Logger Pro. They end with CMBL. You'll have to download, you can download all of these at once by selecting them all. It will download a zip file, and then you can get the files out of the zip file. Or you can go to the other folder. They have AMBL, and that's the one you would use with Veneer Graphical Analysis, that software. Okay. Again, you can select all of them, download them. It will download as a zip. Then you can export them and analyze them. You have to have the software to open it. If you open these in Google, it's a giant text file with thousands of numbers in it, and it doesn't make a lot of sense. So that's a real quick walkthrough. I will have a couple of other videos and assignments to go along with this.